Hello, this will be the demonstration and user guide for the operating systems group project that my group has done. So to start out, what you're going to want to do is enter all these commands. So first one is where I'm going to have it. I'm going to have it in my documents. Next up, I'm using this clone command. This is our GitHub link. We're changing directory to that, and then we're opening up in Visual Studio Code. So once that's done, you have to go to your requirements .text, and what you're going to want to do is install those. So just a pip install the requirements, easy enough. I already have them all, but once that is done, you should be ready to go ahead and start running the code. So first up, we're running one process. Basically all it does is all the input images, here we have 16, each of them go through a total of 256 augmented image changes. Basically all that does is you have a whole list of transformations right here, and then right here we're basically having recursion done to them, so one will get this effect, then that one will then get this effect, and the one that got this effect will get this effect, and so on. Basically it adds up to 256 different images, and they all get sent here. So we got couch, jet, and temple done so far. We'll go ahead and look at jet. As we can see here, all these are augmented images, a total of 256. If we were to click on one of them, we got here an augmented image of a jet. It looks like it was twisted, grayscaled, and kind of changed with the corners here, but we can still recognize that's a jet. Basically, this will all go through all the images. It requires a lot of memory, so make sure you have memory for this. We're going to go ahead and wait for this first one with one process to be done. See, they're finishing up. Okay, so we just finished up. It took, let's see here, 88 seconds to run in one process. So basically all this is going to do is go through 1 through 16 processes, and at the end it will make a graph. So in the time being, I am going to pause the recording, let this run through, and then I'll show it later after all 16 processes have ran. Alright, we are back. Now we can see that it has finished running the first batch of processes, which is or first batch of images, which is largest to smallest, 16 images. So what we end up with here is a graph. So as we can see, with one process it took just shy of 90 seconds, two processes about 46.5 seconds, somewhere around there. Slowly declined till about 5, which is usually about the most optimal when I run the simulation, and it usually slowly increases because the time to create the processes starts to outweigh the actual work being done by them. So this is the largest to smallest. Once I close this, it's going to go ahead and start smallest to largest, which will be slower times because we are currently optimized, well, somewhat optimized to have the highest runtime with largest to smallest. There are other ways that we can completely optimize the uptime of all the processes, but largest to smallest is generally pretty good for it. But next up we'll be doing smallest to largest with 16 images, which will be a bit slower, and I'll go ahead and close this out. This is going to go ahead and start with one process, and I will return after that is done. Alright, we are back, and it is now finished the smallest to largest 16 images. So we get here is another graph. As you can see here, the times are a bit longer because smallest to largest does not optimize for maximum process time up. So this will be the graph we get. So to gather more results, what we did in our report is actually inside of the input images we only used 8. So basically what I did was I tossed 8 of these aside and then ran it again, and that's what returned the other graphs inside of our report. But we're not going to do that for the purpose of this demonstration. We already showed that it works. It runs both smallest to largest and largest to smallest. That should be all of the information needed to run this. If there are any questions, please do not hesitate to reach out to us. But yeah, let us know if you have anything else you need.